Welcome to Lesson 1, More Exponent Laws. Here we'll look at an exponent law called power of a power. So we will expand the following to determine a rule when you have a power of a power. So what does a power of a power look like? Well, if we look at number 1, you'll see that we have a power where the base itself is a power. So now let's expand this out. 2 cubed to the power of 4. What does that mean? Well, it means that 2 cubed is being multiplied by itself 4 times. Now if I expand out each power, 2 cubed, that means 2 times 2 times 2. I'll do that 3 more times. Giving me a total of 12 2's. So I can write this as 2 to the power of 12. Now for number 2, I have negative 5 to the power of 4, all squared. So negative 5 to the power of 4 is being multiplied by itself. Now if I expand out negative 5 to the power of 4, then I have negative 5 being multiplied by itself 4 times. Giving me a total of 8 negative 5's. This is negative 5 to the power of 8. So now what do we notice with the expression we started with and then the power at the end? Well, if you look at the exponents, 3 times 4 will give you 12. And 4 times 2 will give you 8. So if we multiply our exponents, we can write it as a single power. So we'll make that note now that the number of bases is equal to the product of the exponents. So now the power of a power exponent law states that if we raise a power to a power, we multiply the exponents. And the mathematical definition states that if m and n are whole numbers and a is not equal to 0, then a to the power of m to the power of n, that is equal to a to the power of m times n. Now we're going to look at the power of a product exponent law. So this states that when a power is applied to a product, then the exponent is applied to each base. So if m is a whole number and a and b are integers, where a and b are not equal to 0, then a times b to the power of m, that is equal to a to the power of m times b to the power of m. So the exponent got to be applied to each base in the brackets. Here we have the power of a quotient exponent law. So when a power is applied to a quotient, the exponent is applied to each base, similar to the last exponent law. So if n is a whole number and a and b are integers, where again they're not equal to 0, then a divided by b to the power of n, that is equal to a to the power of n divided by b to the power of n.